Hello again. Thank you for joining this section. We are currently in the fourth section of the Information Security Training for Catholic Graduates Association of Nigeria, Enugu branch. And today we'll be looking at cryptography. Cryptography, a very important topic in terms of meeting the three security goals of cybersecurity, which is confidentiality, integrity, and availability. But this time around, cryptography is one of the tools that could be used to deal with two of those attributes, that is confidentiality and integrity. So we'll hear more about it and in today's discussions. So let's start out. The agenda for today. First, we'll provide a review of what happened in the previous section. Then after which we look at cryptography generally, provide some introductions and for us to get to know what cryptography is all about. Then after which we'll look at the catch-off principle, which is a very important principle in cryptography. Then we'll also consider the different types of encryption and then hashing. What exactly is hashing? Then in conclusion, we'll summarize what we've learned for today and what we'll be looking at in the coming week. So let's start out with what we did in the previous week. In the previous week, we looked at how the CIA model and the AAA model can be used to explain the activities of cybersecurity. Then we also talked about security and availability, where we actually emphasized the fact that cybersecurity is all about trade-offs. You have to decide which of the security goals are more important, whether is it availability or is it security. And we also observe that security and availability are just like two sides of the coin. If you try to improve one, the other one tends to suffer. If you try to make information information available to as many people as possible, there are likelihood that the security of that information is going to suffer. And when you try to restrict access or provide security to that information, then the probability that the availability of the information would also have to suffer too. So it's just like we mentioned that security and availability are inversely proportional. So that is what we were able to learn in the previous week. So this week we'll be looking at cryptography. So what exactly is cryptography? For us to understand what is cryptography, already within the week I provided some reading materials that most of us were asked to go through and understand. And in the course of the week, we had some interesting discussion. I must comment most of us. The participation in the discussion forum was quite impressive, and I must say thank you all for making that happen, because I can say, and to tell you the truth, I was able to learn one or two things from what the participants were sharing, and that is the beauty of this whole training. We all continue to learn because everybody tends to say the same stuff from two different perspectives. So, and those perspectives brings the diversity that those perspectives bring into the picture, makes the learning process an amazing experience. So we talked about cryptography, and there were several very nice definition that were provided by most people based on what they were able to from what they understood from what cryptography is all about. And for us to understand this, just like a sort of summary, that's what I'm providing in this training, in this particular section, try to provide clarification and also provide some insight for us to better understand the concept that we studied in the previous week. So cryptography, we can look at cryptography from the actual Greek word because it's a Greek word, right? The first part is the crypto, which means hidden, whereas the graphy is written, right? So if you try to combine the two, it's more about the science or the process of reading or writing secret codes, right? Now, this is beautifully conceptualized by the diagram we have that we are seeing in this picture. We have the plain text. The plain text is the one that is readable. Like, let's say, Obi is a boy. Obi is a boy is a plain text, right? That every other person, if you understand the English language, you should be able to read Obi is a boy. Now, if you want to perform this cryptographic activity for this particular plain text, the first stuff you do is what we call encryption. Encryption, if you look at it, is you're trying to make this readable plain text into a ciphertext. And most times what is done is that you use a particular key to be able to convert that Obi is a boy into a ciphertext that only the person that is intended for and who has a key to decrypt the ciphertext is able to make sense of whatever you have sent. Take, for instance, like a typical example is what we have by what happened during the Greek, no, during the Roman Empire, where Caesar has to communicate with his general. He has to communicate with his generals, but he does not trust the sender. He just assumed that maybe the sender, the messengers are likely to divulge that information to the enemy. So what he does is to add some additional key, some of those words, whatever he's sending, he shifts it by 3, right? Such that it is only the general who knows that that all what is written is shifted by 3. That is the key. The shifting is a key. He's the only one that is able to make sense whatever he receives from the messenger. So that is the idea of cryptography. First, you have a plain text, right, which you use a key to convert through the process of encryption into a ciphertext. Now, that ciphertext can only be returned back to its original form, which is the plain text, through the decryption, and that decryption is done by the person who has only by the recipient who has the key that is able to make sense of whatever that is sent. Now we can see the application of cryptography in fact, all our lives, in every aspect of our life, we can see cryptography in action. Take, for instance, you sending a message across the internet. So because the internet is untrusted network, what happens is that everything you send in is encrypted and sent through this untrusted channel, such that if an adversary intercepts that message, he cannot make sense of whatever is being transmitted across those lines. So that's the typical example where cryptography is being applied. Also, you have your phone that's you most times try to encrypt some of your files that you just want only you to know what exactly it is. If you peradventure had to lose the phone, anybody that have access to that phone cannot make sense what you have in that phone, because everything has been encrypted, because this is your private files that you don't want people to have access to. So this is mostly about cryptography, right? Just the idea is to make convert a plain text through encryption process into a ciphertext, and that ciphertext can then be returned back to the plain text through the process of decryption. All that happening using all that happening using the key, right? So this is it for cryptography. Right then, I think uh, the other most discussions we had was centered on trying to make sense or trying to provide a scenario where cryptography can be applied. And so what we'll do now is that if you let's just consider some of the scenarios in our private or professional life where cryptography can be applied, and think about it and see if you have any thoughts you could share with us. Then if there are questions that something you're not clear about regarding what we studied in cryptography, that's the basic introduction to cryptography, then you can go ahead to ask. Let me provide that clarification.
Okay, hello.
Yeah, go ahead.
Okay, mine is kind of a question.
Okay, good.
That's if it can actually apply or we can call it cryptography. Where I work with a HMO, and then
Okay,
we partner with NHIS and then hospitals.
okay.
Now, us being the HMO, we usually issue an authorization code to treat our enrollees, our clients.
Mm-hmm.
Now, can we call that authorization code our issue that kind of is a form of cryptography? Because most times anybody outside this sector may not understand what that code stands for, but the HMO and then the provider, which is the hospital, we do understand the meaning of those authorization codes. Can we still call it cryptography?
Not exactly, because now when you issue the authorization code, is there any form of like encryption that is done in such that
Yes.
pardon?
Well, for instance, the code comes in this format. Maybe, for instance, today is 5th. The code will come in the form of 005
Mm-hmm.
007 apostrophe 0.
Okay.
Can we call this kind of thing a kind of, is it a form of
No, no,
encryption?
no, no. Yeah, yeah. It's also a form of encryption because since you've just divulged that information to me now, I wouldn't have known. Do you get the idea? I wouldn't have known.
Yes.
Do you get it now? If I
Okay.
if I come into your office and see that now, I don't even know what it is. It is only someone who, like for instance, you that is a staff that understands that this 00, look at this, what it means, right? Then perfect.
Yeah.
That is also encryption, but this is not like a sort of a strong form of encryption, right? But we can say it is encryption because without knowing what they are for, take for instance the case of Caesar that I mentioned, that the messenger asked to send a message to the generals, right? And he shifts those words using a key. He just shifts. The shifting might be instead of maybe he can. Let me just give an instance now. I am sending you a message, right? And I write that message in numbers. Do you get it now?
Okay.
When I write it
Yes.
in numbers now, and because you know that, okay, because that I'm writing it in numbers in the sense that each of those numbers, if it is one, that one is standing for A. If it is two, that two is standing for B. Do you get the
Okay.
idea now? So you're able to
Yes.
translate it, you're able to convert it to text yourself.
Okay.
So that is the same sort of thing that the 00 stuff is. It is only you who works in that sector that understand what it is, right?
Yeah.
So that is maybe we'll say it's encryption too. because it's for people that it's not intended for. It is unintelligible. They don't know what it is. They don't know what they could even use with that do with that sort of information.
Okay, all right.
Okay, I have Evans
Okay,
on
good.
the
Go
line.
ahead.
I have an instance which we use in our office,
Okay.
being radio message and even official messages if we don't want an outsider to understand.
Okay, good, good.
It's run to me.
Mm-hmm.
I will just say Yankee Echo Sierra.
Mm-hmm. Mm-hmm.
Yankee Echo Sierra Papa Alpha Yankee.
Mm-hmm.
This Yankee Echo Sierra, Y is standing for something.
Okay, okay. It's better you say something. Please don't tell me because I might use it.
No, what I just want to say is not a bad thing anyway,
No, no, no.
because
I
I didn't
understand
use
because it's
I
that
didn't
same
use a
form of
sensitive
encryption that
one.
we're talking
Yes,
encryption we are talking about.
yes, I simply want to say yes, yes, salary. That is, if somebody wants to say have they paid salary, I will say yes.
Mm-hmm.
Yeah, yes means Yankee Echo Zero using the code,
Mm-hmm.
and
Mm-hmm.
Papa Yankee. If it P stands for Papa, A stands for, as in if you translate it, pay means Papa Alpha Yankee
Mm-hmm.
means yes, salary or they are paid salary. But you don't want an outsider to understand because of security implication, you might get attacked or thereabout. And we call it a sort of encryption.
Yes, because if I don't know the translation of those codes that you were saying that Y stand for this. So this Y stands for the yes and all that. This is just like the key, right? The key that would help you decrypt the message that has been encrypted because it's an encrypted message, right?
Yes.
Such that anybody that it is not intended for would not even know what it is about. So it is a form of is an application of cryptography.
Okay, thank you.
Okay. So are there any questions maybe that require that maybe something that is bugging your mind about cryptography that we studied within the week that you want to ask so we can provide that clarification and answer.
So yeah, I want to do something.
Okay, go ahead.
Just to, I want to ask whether that this writing category, I call it category, all those fonts like police and they call it a signal. If you find that if they
Yeah,
classify as
Chika, can you
program,
please speak up a bit?
Hearing you is difficult.
okay, can you hear me now?
Yeah, beautiful. Yes.
I'm saying that the kind of signals, all those in force like police and military, they are using to transfer. They call it signal.
Yeah.
So there's a scenario that happened one certain time, and there's one PSP I'm working for. One day they gave me a letter to send an email for him to the particular man. Maybe but what I'm seeing there is all symbols, signal, not dragon.
Mm-hmm.
Then the person received it and they replied the message.
That is perfect application of cryptography because that message is not meant for you. It's actually intended for a particular recipient who has the key. The person he has the key. He knows what each of those words stands for. So what he used in translating it to a plain text because what you was sending across is what we call the ciphertext, right? So whatever he's going to use to convert it to a plain text that even you can understand if you know it, that's the key. Do you get it now? Hello, Chika. Hello, Chika. I think we lost Chika there, but what he described is a perfect example or perfect application of cryptography. So any other question? Alice, I appreciate that people are sharing a scenario in their private and professional life where cryptography is applied. So it helps us get a better understanding of cryptography itself. Right. So any other question? So if there are no other questions, so let's look at the Kirchhoff principle. Right. Now, it's actually an interesting principle, and many of us had some interesting things to share during the discussion in the course of the week. The principle said that the design of a system doesn't require to be secret. It doesn't require secrecy, right? You should make it open to everybody to see. But what you should make sure that is safe and secure is just the key. Because if the design for you, if the key is lost and you want to change the key, it's very easy to just change the key, right? But if you make the design of the system very secret, right? And you have to maybe in one word or the other, it is late, right? It does mean that in everywhere the system is installed, you have to change everything completely, which will be a very difficult thing to do. So the design, this principle say that the design of the system should not be secret. It should be open. That's why you will see open source. Most of these cryptographic algorithms are open source. People are allowed to attack it. People are allowed to, find bugs and try to resolve them, right? So because it's just allowed to be open, so what you just need to do is to ensure that the key is secret. And with the key being secret, just take for instance a perfect example of this is the door in front of your house. Everybody knows where the door is, right? Everybody can just see the door. You don't need to keep that door secret. But it is only the person that has the key to that door that is able to open and access it. That's just a typical and a perfect example of this principle. So with this now, we've seen this application in several algorithms that are currently in use. The only organization that tend to keep the design of their system secret is the CIA, because when you join the CIA, I guess it's a very secretive organization that they are able to keep and ensure that whatever design they have is perfectly secret. So they are the only one that could come up with that. Apart from them, I don't think there is an organization that is able to keep the design of their system secret and still able, because when it is leaked, it becomes a problem for wherever that system is installed. So this is the Kirchhoff principle, and if you have any question, or maybe let's start with reflection. Think of an application of Kirchhoff principle. We've seen that application, but like for instance the door that I mentioned. But if there are other applications that would help us conceptualize or help us imagine or appreciate the Kirchhoff principle, which is a very important principle in cryptography, you could share with us. And if there are questions or clarification you have for this Kirchhoff principle, you can go ahead and ask them so I can provide them. So any question about the Kirchhoff principle? Anybody want to share about any application of the Kirchhoff principle? Hello, do we still have people around?
Yes, we are here.
Okay, so it actually means that the catch-up principle is very clear, and we can proceed to the next to the next one, which is the different types of encryption. These different types of encryption. Okay, good. Now we also saw the different types of encryption. Somebody wants to say something?
Sorry, it's a mistake.
No, no, it's okay. It's okay. Okay. Now we also saw the different types of encryption within the week, and we have the one they call the symmetric encryption, which is also known as the private key encryption, and the asymmetric encryption, which is also known as the public key encryption. So from the diagram we can see, now it's a very simple illustration, right? In the private key, in the symmetric encryption, the same key is used both for the encryption and the decryption. The same shared key is used, right? Because if you remember, if we're doing the encryption, if you from the other side, you're doing encryption when the message is being sent, because you have to convert the plain text message into a ciphertext before sending it across. When it gets to the recipient has to perform another operation, which is the decryption, by using a key to convert whatever the ciphertext they receive into a plain text back. So just to complete the whole process, the cryptographic process, right? So when you use the same key, which is a private key, for the encryption and the decryption, that's what we have as the symmetric encryption. So we have there are several types. Somebody is saying they cannot hear me. I just wanted to confirm. Can everybody can others hear me?
Yes, I can hear you.
Yes, I can hear you.
All right, thank you. Maybe Tochukwu,
I can cloud.
Tochukwu, if you can try to rejoin again, because others can hear me, and I don't think it's a problem from my side. Okay, so let's continue. So in the public in the public key encryption, what we have is first you have to. It's a two-way. Is an additional sort of layer that is added, right? First, you encrypt with with a private key, right? With an additional public key of the recipient. Then you encrypt it again with the public key of the recipient, so that when the recipient receives it, right, the public key is public, right? It's just like I'm just trying to get a better way to put this across. Like, take for instance what we have in certificates, this certificate authorities, right? Because most of them have in the certificate authority. Then if you okay, now I'm trying to get a better way to explain the asymmetric encryption. We have a combination of both public and private key that are accepted, such that when in the process of the encryption, you encrypt it with the public key and also the private key of the recipient. So when the recipient receives it, Now, using his public key, he's able to decrypt the message with an additional his own private key. Does that make a bit sense?
Yeah.
Okay, because now we have typical example, the example of that, which is the SSL slash TLS. That is an application where they use the RSA. RSA. Do we know the RSA? RSA is the public encryption method that we have. RSA is actually the owners, the people, the guys that came up with the RSA, right? What is the reverse Shami Adema, right? Adlima, right? That is what they use in naming it the RSA, because it's the first name of that's the last name of the individual authors of this encryption key. That's the first public key encryption that we have, right? So as I said, right, you have first the public key. The original message is encrypted with the private key, right? And the public key. The public is is a general key, public key that everybody knows about, right? Then where the receiver has to decrypt the message with their own private key. So the sender sends the message with a public key and the private key of the receiver. And the receiver has to decrypt it with his own private key, because the public key is already known to the general public. And the practical application is what we have in the SSL TLS that is used, is the popular protocol that is used for websites. If you look at some website, that if you have a secured website, it means that it is running this SSL and the TLS protocol in it. That's what ensures its security, right? So already I've mentioned an example where it is commonly used, but if there are additional suggestions or maybe thoughts about where these keys are used, you could mention it. And if there are questions about the encryption, then maybe we could hear them.
Yeah, Obi,
I want to ask. Hello?
Okay, yeah.
I want to ask, because we have a scenario like the national driving license and the number plate where I work. There are physical features there, which anybody can look at, and also there are also securities. I can call it maybe a public key. Anybody can look at it. It's secured and all that. But for us who are working internally, we have a kind of a private key, which we can send across, and the person uses also a private key. The person in the database to also reply to us exactly the content of the license or the number plate, and from there we know whether it's stolen, it's fake, and all that thing. We use it to track vehicles, stolen vehicles, and forgery and all that. I don't know if this matches this scenario.
The illustration could actually work, but In this case, what we have is actually a type of cryptographic system, right? It's actually in existence, not just like would I say conceptual idea.
Okay.
It is actually, but the explanation you're giving, yeah, could kind of be used to think about it, right? But in this case, the RSA, which is an example of a cryptographic of a public key algorithm, it's already implemented and it's being used. But thank you for sharing. I guess no. So you want to say something?
Yes, I wanted to add to what you said, just to see if it will help our people understand more. So what Obi is explaining is this key is a two-way key. It's just kind of a key that is divided into two, and one of the keys sent in advance to the person that is receiving it, and the person saves it in his system. Without that key, that you save one on the system, and then the public key is shared with the person. So the one is already on the system, one is shared with the person that will log in. So if you that have the public key want to log into that system, which is the center, you must have that public key. So when you now want to, let's say, like Obi said, SSH, like secure shell or secure login, you bring what you have as public. Only if it matches what's already on the system, then the door will open for you, you come in. But if you have something that doesn't match, there's no way you can log into the system. So that's where it's being used, like when you're doing SSH. Thank you.
All right, thank you for providing throwing more light on it.
Okay, I want to ask a question.
Okay, go ahead.
Is there any extra effort that should be made in order to make sure that the key that is sending to the recipient is more secured? Like, is there any extra effort that could?
Okay, that is the problem with the symmetric algorithm, right? Which is called key management. In the remember there are two types of encryption. The symmetric, where you use a private key, right, for both, where you use the same shared key for the encryption and the decryption, right? Now, the biggest problem for that type of encryption is how do you ensure, right, that key does not get into the wrong hands. Do you get it now? Which is the key distribution. So, to solve that problem, the public key encryption is used. Do you get it now?
Yes.
So, but if you have a way to securely share the key, right, then it's not a problem. You could go ahead and use the symmetric type of encryption, because now you're sending it. Take for instance, okay, let me say it. For instance, now you sending. There's a way you could think of this now. There's a way you could try to resolve that. Take for instance, you send a message across the internet, right? The message has been encrypted, and you're sending it across the internet. Now, the key that will be used to decrypt that message, what you try not to do is to send the same key across using the internet. Instead, maybe you use surface mail to send the key across to the person. Do you get the idea?
Okay.
Right. Yes, they use the same sort of similar thing here in Norway, where your account, when you open your account, right, the account is on the internet. Now, the PIN that you're going to use to operate that account is sent to you via the surface mail, not through the internet, because it's assumed that the internet is not secure and somebody could intercept it. Do you get the idea? So it is sent across using the surface
they will bring it via letter to your house.
Yeah, they bring it down to your house, and you confirm that you received it yourself.
Okay.
Do you
I
get
think
it
that's
now?
perfect. It will work. It will work.
So that if you have a way to, because now if you have a way to manage, that's a key management problem, which is a very big issue when you're doing symmetric encryption. If you have a way to ensure that this key is securely sent to the recipient, the intended recipient, then
Yeah.
it's much more better. It's a much more better form of encryption.
Yes.
Hello.
Get the idea. Lillian,
Yeah.
you
It's
want to say something?
Hello. Okay, I think we can relate it to the ATM card too.
Okay.
Maybe you want to get an ATM for your account,
Yeah.
and after getting the ATM card, they give you your PIN maybe through the envelope instead of sending it through anything. And maybe right there, you key in your PIN, and they ask you to change it immediately right there. I don't know if that applies to.
Yeah, because the pin, that's the key. Do you get
Yeah.
it now? That's the key that you could use in having access to your accounts, which should be private, which is actually restricted. It is only intended for you, right?
Yeah.
And that key, which
Yes.
is your pin, the ATM pin, provides you the key to use in accessing it. It's something you can also imagine it that way too.
Yeah, I want to say something like mostly statement of accounts that the bank normally send to their customers.
Chika, if you can come close to your phone, we'll struggling to hear you.
Sorry. Can you hear me now?
Yes.
Okay, I'm saying like this is the idea of this account statement that banks normally send to their customers.
Okay.
And
Yeah.
when they send you such a statement of account electronic and based on from your mail, they will ask you to use so they will give you a particular code or they will ask you to use the 4 digits of the account number to open it
Mm-hmm.
on that
Yeah.
statement of account. So does this match any of the types of encryption here? The key now is it private or public?
Now, because now the what they are doing is not like a perfect form. It's not that perfect, right? But maybe it's also a way of ensuring the confidentiality of your bank statement. Because the bank statement is sent to you, and they say it is only, maybe they ask you to use the last digits of the last
Account
four
number.
digits of your account number, or your card, to access
Yeah.
it, right? Yeah, it's also a form of encryption, but why it is not perfect is that if I know your account number, which means I could access it, it's not that as strong. It's a weak form of encryption. Do you get it now? But still, it's intended to be a form of encryption, because you can either have a weak or a strong form of encryption. Do you get it now? All right, then if there are additional questions, or maybe if you want to uh, share an application that you could think of. Okay, if there are none, we can now look at the last one, which is the hashing. Hashing is quite interesting because some of us actually confused I think confused hashing and encryption, right? And also the goal this in the CIA security goals, what hashing is actually helping to achieve. With the interactions we had within the week, people tend to confuse those two. Then clearly you can see from this simple diagram we have here, hashing is just a one-way function, right? You have a hashing function or hashing algorithm which acts on a plain text, and you have a hash text. That is it. You cannot combine this hash text, right, to go back to the plain text like we did in the encryption process, right? So that's the difference. You remember in the encryption and decryption. This one, you convert the plain text to a ciphertext, and that ciphertext can be returned back to the plain text using decryption, and using the key for the decryption process. But in hashing, that is not the case. Hashing is a one-way function that when you apply the hashing algorithm, you cannot go back to the plain text again. And now the application of this is what many of us seem to not actually get right. In hashing, what you try to do is to ensure, because in hashing you cannot have two words or two types of two different plain texts cannot have the same hash, because the hash text is actually called the message digest, right? So this message digest you can have the same message digest for two different plain texts cannot have the same message digest. It's impossible. When that happens, it's what we call collusion. If it happens, it means that the hashing algorithm has to be retired. You don't need to use it again. That is a problem we had with MD5. There is this hashing algorithm that is called MD5, and also there is another one that is called SHA-1 and SHA-2, right? This one, most of them has been retired because of this collusion, where two plain texts have the same message digests, right? So one of the most commonly used hashing algorithm is the SHA-256, right? Which ensures that there is no collusion. So how do we apply this hashing? Just some thoughts on how that can be applied. I think I provided this sort of description to some of those that responded to the question and did not get it right. I tried to provide this explanation to them. Now, when you download something from the internet, right? Remember, it's assumed that the internet is not secure. Anything can happen in between during the time you're downloading, you're pulling it, right? Something must have happened. Somebody must have there are likelihoods that someone can intercept and provide you with something that you did not even ask for, something different from what you downloaded. So anything is possible, right? So if you want to ensure that what you're getting from a website, right, is the same from what is actually on that website, so you can use this hashing, the message digest. First, you will just, when downloading, there is a message. Any download, that's whatever you're downloading on a website, if you look at the details of it, you can see the hashing, the message digest, right? The hash of that download. You can see it on that website. It is permanent there. You can always see it there. Then what you do is that after you download whatever that you're downloading and you have it on your system, you run a hash, you convert it. There are several hashing websites that you could use. You just if you just type on Google hashing website, right? You could even find one that you could use. Put in whatever you downloaded and hash it. Now the message digest you get from that hash, it must match. If you want to ensure that what you downloaded is it has not been altered in any way in transit, the hash of whatever you download must be the same with the one on the website you downloaded it from. That is a way of checking integrity of your download, to ensure that whatever you download has not been altered in any way while in transit. Do you get the idea of hashing now? Hope the idea of hashing is clear. So we could like I've also already answered this question. Now hashing, if you compare it with the CIA model, hashing relates to the integrity attributes of this CIA model. Although some people tend to mention confidentiality, that is not really correct, because hashing only relates to the integrity. You just want to ensure that whatever you receive has not been altered in any way in transit. So you could also try to think about any other way you could apply hashing in your private or professional lives, or if there are questions about hashing that you need to ask, you could go ahead and ask.
Okay. Hello.
Yeah, go ahead.
Okay. I think the topic of hashing is becoming a bit clearer.
Okay.
Still on my workplace. Now, when we issue this authorization code to a hospital,
Yeah.
if it's a case of a referral from one hospital to another, usually the referred facility, that's the hospital that this client was referred to, usually call the HMO to confirm if that code given was actually issued by the HMO. Is it also a form of hashing?
Now, when it's going to be, because you people, because what you're trying to do, you're trying to use a manual way, right, of approaching the problem. Now, if you want to automate this whole process, that is where you can now apply hashing, such that when each authorization that is issued, right, because you don't want people to see that authorization because it's dangerous, you could hash that authorization. Do you get it now? When you hash that authorization, then you put it somewhere on your website, for instance. You put that the authorization, the hash of that authorization on your website, right? So that when the person that has been referred to get to the hospital that they referred them to, instead of calling you to check, right, what they only need to do is to go to your website, which you have provided access to them. Do you get it now? So what they do is to also hash that authorization that the client, the person that was referred to, gave to them. When they hash it, now they now come to your website and check whether that hash is equivalent to the hash that you have on your website. You get the idea?
Yeah.
So they don't need to contact you again. They don't need to contact you again. So they only go to your website that you provided them access and check that the hash of the authorization that the patient came with matches with the hash that is on the website that you have provided them access with.
Okay. Now I have a question now.
Okay.
This hashing and then encryption. In that case of encryption, that Caesar, the military man, he was using the key 3. So wherever you see 3, now, does it mean that anybody can decide whatever the key is?
You can decide whatever the key is.
It is. Okay, that's for encryption. That one is clear. Now, in hashing, how do you go about it? Is it still the same issue of giving a key, or is there another methodology for doing that?
No, hashing, there is no key per se, right? There is an algorithm there which is called the hashing function that you're going to use. There are different types, but the one that is now commonly used now is the SHA-256, right? There is there's one they call MD5. There is one they call SHA-1. There is also SHA-2. But the one that is currently being used now is the SHA-256. Now, why the other 3 why they were retired is that now in the MD5 there was a problem. Now, if that, you remember the authorization code you talked about.
Okay.
Now, that authorization code should not be the same with any other authorization code. If you hash it, the hash of that authorization code should not be the same with any other hash of another authorization code. Now, when the hash of the authorization code is the same with any other hash, that is what we call collusion. So it is something, it's an undesirable condition. Any hashing function that collision occurs should be retired. So that's why the other ones were retired. Do you get the idea now? Because you don't want the same hash of an authorization code should be the same with anyone.
Okay.
Does that help?
Yes.
Good. So the hashing function is an algorithm that has to be run on the plain text for you to get the message digest, the hash of the message you're trying to convert using the hashing method.
Okay. You said something about going to the internet. If you want to run a download.
Yeah.
Maybe I've been seeing it, but I don't know that this is the hash digest. How does it look like? So that maybe if I run a check now, I can actually confirm.
Okay, wait. Let me. Maybe we'll do a little demo. I'm just coming. Let me get a hashing stuff here.
Okay.
Hashing website, so you can see what a message digest look like. Just if there are other questions, you can go and the person can go ahead and ask while I bring up the hashing stuff. Okay, now maybe we can use the one for SHA.
Can I ask a question?
Okay, go ahead. Yeah.
Yeah. So can we say that the hashing algorithm is the same thing they use in generating like driver's license ID or plate number?
No, not really. Okay, now I have gotten the website. Let me share my desktop here. Can you see my desktop now?
It's loading.
It's loading.
Can you see it now?
Still loading.
How about now?
Yeah, I can see it.
Okay,
Yeah,
good.
I can see it now.
Good. Now, if you can see now, this is a hash generator. You can see the different hashing function we have. This is the SHA-1 that I mentioned. This is the SHA-25Cs, and this is the SHA-512. Now you can just write. Okay, let me just say this is the hash of my name, Livinus. Can you see this?
I'm sorry, I have a grammar here. Someone is presenting content using a sharing or recording feature that your version of the app doesn't support right now. I don't know what the problem is.
Okay, you cannot see.
Yes, I can't. You see the issue of system or phone?
Okay,
I can switch over to phone. Yes. Is it an issue of system?
Okay, but others can see, right? Okay, but can others see?
Yes, I can see.
Yeah, I can see.
Now, Gerard, maybe I'm going to share this with. I'm going to share this.
I'm not seeing it as well.
Oh,
I can see.
but okay, I'm going to share it on to everyone on the chat.
Okay, all right.
Use this.
I can see it, but there are some extra charges.
Okay, use this website that I shared on the chat, right? Go to the website, then you can see. Just type in the text. Just enter any text, and then you can now see the hash that will be generated. Look at the hash that was generated for my name, Livinus. Then you can see the hash now. For those that can see, you can see the hash that was generated, right?
Yes.
Yeah, so this is what a hash function looks like. That's a message digest. This is the message digest. This is what it looks like. So others can go ahead and take a look at it. Maybe we can just continue. Let me exit since many people are some people are not seeing this. Let me exit from. So let me continue from the where I'm trying to upload the.
Okay, so I have a question.
Okay, go ahead.
Okay, so can we say that the hashing is a better way of securing a document?
Okay, now hashing on its own, it's not like a better way of securing a document, but it's a way of yeah, because it's also a way of it's just a way of ensuring the integrity of the document.
Okay.
Yeah, which invariably you also said, because if you're ensuring integrity, you're also trying to ensure security, because integrity is one of the three attributes of the security goals. So it's also another way to put it.
Okay.
But
and the only disadvantage is just that it's a one-way message. Like you cannot go back.
no, it's not a disadvantage. That's just the way it works.
Okay.
Do you get that? Is the way it's meant to work.
Okay.
Do you get it now? Because take for instance okay.
Sorry. Can we say that hashing is like a label that you put on something and only that thing has that label?
Not exactly. No. It's just like okay, you have you know this juice, right? You have a the normal fruits and you put it into a blender and you blend it, it becomes a fruit juice, right?
A fruit juice, yeah.
You cannot return it back to the original the original form it was before.
Yeah.
It is not a disadvantage that you converted. It's because you wanted to do that. Maybe because you prefer to take the juice instead of eating the fruit, the weight. You get it now, right? But in this case, the idea is just for us to provide a sort of a way of checking the integrity of the file or the documents that we are sending, because the internet is untrusted channel. Anything can happen in between. Anything can happen in between in transition, right?
Okay.
Because because now the question is, how sure are you that what you are receiving is what was sent from? Because now you downloaded something from the internet. How sure are you that somebody have not altered that information in transit?
So hashing can it be likened to like verification?
Yeah, beautiful. It's a way of verifying. It's just like a way of verifying, right? That what you've received is actually what was sent or what you requested for.
Okay.
Do you get the idea?
Okay. All right.
Okay.
I want to ask.
Okay, go ahead.
Can we also liken hashing to barcode, which have to scan and see information?
But you say?
Can we liken hashing to barcode?
Barcode? No, because barcode is a different thing. Barcode, you're using barcode for like for barcode, you're trying to use it to identify. You're identifying an item, right? You're using it to identify, to provide a unique identity for a particular item. But in the hashing, what you're trying to do is to verify. For instance, in that let's take for instance maybe that item that has a barcode, right? And you're not sure what would happen, and you just want to ensure that anybody that gets that the item, right, it's actually coming from where it was sent. Then maybe you now convert that item. You have a hash of that item on the owner's website or the owner's anywhere the information can be stored, right? So that when you receive it, you're able to also convert the if you want, if you're like maybe you want to be extra you want to be extra sure that that item is actually coming from the original sender, you have to convert that item, hash it, and now check the hash that you generate with what was sent in, with what is available in the owner's website or owner's store, just to confirm that it is actually coming from that owner, because you don't want to buy the same item from another person, maybe because that you think that that item has been faked already. Do you get it now? You want to ensure that what you're getting is not the fake version of that item.
All right.
Does that make sense?
Hello, Obiora, please,
add
I have a suggestion so we can get this thing clearer.
Okay.
Now, is it possible that this is your YouTube channel that we usually go to? If we miss out any of these sections, we can check in there. Is it possible that you can do this hashing? Maybe we'll not try it out so that we'll maybe more practical than. I think it's more abstract. That's why we're confusing it with so many things.
No, I
If we
just
can
did
use
some.
that.
I just for people that saw the hashing stuff, but you saw the hashing I did, right? For those that just saw what I did when I shared my desktop.
Yeah, it was done.
Yes, but and you can even go ahead and with that the website that I shared on the chat, you could just log in. It's just a website. You can log in, then try it and see the hash of whatever you supply to it. Then the same hash, right? Then copy that the same hash and keep. Put a different text, and you see that you are going to get a different hash, right?
Okay. My challenge is that I can't even view that. That's my major challenge. Yeah.
But can you
Maybe
can you open the chat? Were you able to open the website that I sent?
No, I didn't even see it. That's the issue.
Okay, wait. Let me send you the website maybe on your own to you now and again.
Okay.
Okay, this is Jared, right? Okay, now I'm sending it to you. Why can't?
Hello, please, Obiora. Hello.
Yeah.
Please, I just want to ask a little question.
Okay, go ahead.
About this hashing. Is there no possibility that those that develop the algorithm may have another algorithm that will dehash whatever that's hashed?
No, the way it's done, right? That's the actual way it's set up. It's done in such a way that you cannot return back.
But you know, it's an algorithm. That's why CIA can do many things and do without people knowing.
Okay, somebody wants to give an instance. Okay, go ahead.
Okay, like hashing that we're talking about. You know, when you want to go to school abroad, there's something they call verification. Then you send in your certificate to them. Then they will write to your school to tell them to verify if this is coming from them.
Okay.
If what you send is what they have in their record. Then that's a scenario. Then hashing, this like you going to a site using an algorithm or an established algorithm now without asking anybody. You type in whatever you want to hash and check if what you have is authentic. I don't know if it helps those that are confused. You now, maybe someone sent you a message or you went to a website, you want to confirm if what you got from the website is is real or it's not fake or it has not been tampered with.
Yeah, it has not been
You
altered.
get the hashing, yes, has not been altered. Then you go to the like the site you sent now, like go check and see if it is authentic for you to know it's coming from the right source and it has not been altered.
Yeah.
That's what I understand.
Thank you for the clear explanation. But can you see? Can everybody see the website that I put on this slide now?
No.
No.
There is a website on this slide. You can see it.
Yeah, it's on the chat. It's on the chat.
No, not the chat. Not the chat. On the. I also had to enter it on the this slide that I'm looking at now.
Your projections are not showing.
It's too
no,
small.
we're not seeing it.
It's too tiny.
Okay, it's tiny. Okay, let me increase the size. But I just okay. Is it working? Well, let me just see if I can.
From my end, your
Can you see it
projections
now?
are loading.
I increased it now.
No, it's just loading.
Okay, it's still loading. Okay, that's strange.
It's just loading and loading and loading.
So you cannot see the slides that I'm sharing now.
Yeah.
I can see it. For me, I can see it, but I guess a lot of people can't.
Because what I just did was to increase the size now.
Okay, now that you increased it more, it has gone off the slide. Some part of it you can't see it anymore.
Yeah. Okay, but let me just make it a bit reduce it a bit, make it 30. Okay, make it 40. So how about now?
It's still lost.
Yeah, but no, it's still it's showing now. I can see it here. I've just brought it down here. Can you see it? No.
Let me move you up.
It
stopped at G-E-A-N-E.
Okay. Let me just. It's even the website is even simple. It's just passwordgenerator.net.
Okay.
For me, I can't see anything, please.
It's what you sent in the chat.
Yeah, it's the same thing I sent in the chat. Passwordgenerator.net. Then from there now you can just think look at, if you go down, you will now see which of the generator. Maybe you want to generate MD5 or SHA-256 or any of those hashing function. Then you can now use it. Okay, thank you. Somebody made a good suggestion. Okay, I'm sending it on Slack so every other person can see it there.
Okay.
So any other additional question, because we are rounding up?
Yeah, yes, I have a question now.
Okay,
Hello.
go ahead. Okay, I'm muting them. So, okay, go ahead, Jared.
Okay, I said if someone wants to create a website
Okay.
And then you want your website to be secured, whereby whatever information is pasted, you post there should at least have integrity. Now, which one should be the major concern here? Is it the encryption or this hashing?
Now, if for the website, is like a different thing entirely. Because for the website, there is this what we call if you look at different websites, all right, if you open a website, you will see some that are not secured and some that are shown that is secured, right? So what it actually means for a site to be secure in the actual sense is a site that is using, there are two different what's it called, the two different
So,
I'm looking for the name, but is we have the HTTP and the HTTPS, right?
Okay.
Now,
Yes.
any website that has just the HTTP, it's usually assumed not to be secured because HTTPS have an additional layer of security, which means that it has this SSL/TLS, right? Then, in addition to it, there is what we call certificate authority that you have to pay them. Now, that certificate authority is the one certifying that because they are authorities, they are certifying that this website, right, is secured.
Okay.
Good. If you have a valid certificate, then you will now see, even in that valid certificate, you will now see who is the certificate authority that issued that certificate that your website is secured.
Okay.
So this is an additional payment that you need to make. The person that is hosting the website, if you want this sort of service, they will have to charge you additional money for them to be able to provide that certification that your website to some extent is secure. Do you get the idea?
Yes.
So that is it. So is a service that can be provided by the person hosting the website.
Okay.
So any other question? So if there are none, what did we do today? Just a summary. First, we reviewed the activities of the previous week and tried to provide clarification and discuss the concepts that we learned within the week and reflected on them by providing practical applications and everybody sharing different thoughts on how what we've learned can be applied in their private and professional lives. So in the coming week, that will be a bit more technical than what we saw this week. So you see, we started with something simpler. Now we're going down. It's becoming a bit difficult as we proceed, right? So in the next 2 weeks, we will be looking at networking because the bigger part of this whole thing is networks, right? So you need to know how does the information move in the internet from the source to the destination. What is the whole thing behind it? Some say it's magic, but I can tell it is not. So we are going to take a look at it in the coming week. Then also look at IP addresses, MAC addresses, what are they, how they are being used. Then we'll try as much as we can to provide explanations for them, and we'll try to have fun while doing that. So if there are any other questions, maybe thoughts and suggestions, then we can now have them now. So before we conclude for today. So that is it now. So since there are no questions, so it's good having most of us around, and please keep up with the interactive nature the previous week have been. Please keep it up. I really appreciate that most of us were active and able to make contributions, and that's also motivates the other people who are not actually participating in the whole training. So see you within the week in the discussion forum and through the direct messages. And until we meet again next week, the same time, just please do have a great week ahead. Thank you so much.
Thank you.
All right, bye.